Hi, today we are presenting our project, Infrastructure as Code, Building a Universal Namespace. These are several topics we are going to talk about today. First, let me talk about our project goal. So our project is to deploy a global naming system using the idea of infrastructure as code. So what is IaC? IaC is to manage and provision the infrastructures through definition files rather than the physical hardware configuration or interactive configuration tools like a web UI. Um, and the global naming system we need to deploy is called Upspin. Upspin is a framework of naming and sharing data securely and uniformly. So after we know these concepts, let's be more specific about what we are doing. So what we are trying to do is to automatically provision the Upspin server infrastructures on both OpenStack and OpenShift platform. So on OpenStack, we need to create instance and configure that instance for our deployment of Upspin server. And we'll also use an automation tool called Ansible to automate the whole deploy process. And on OpenShift platform, we use Dockerfile and some necessary shell script to create container with some correct configurations and deploy the Upspin server in the container.
So here's our accomplished progress. For OpenStack, we have a package of well-organized Ansible playbooks with limited user inputs, including OpenStack authentications and Upspin domain settings. And the user could simply run one line of command to provision necessary infrastructures for Upspin server. And for OpenShift, we write a Docker file with several shell scripts to create a container on OpenShift and run an Upspin service on that. And we also met a configuration error due to permission problem we will talk about later next. So firstly, I'm going to talk about the OpenStack in detail. Before running the playbook, user need to provide the Upspin account by signing up by email, and the user need to install the Go environment on local machine. Then after running the playbook, it will help you create an instance on OpenStack platform to run the service and also set up domain for verification to the key server, and also create an A record for its host name and deploy the Upspin server binary file. And finally, it will send some server key and configuration information to the instance. Next. So our Ansible playbooks are organized in a grid architecture, which could be divided into two parts: OpenStack VM instance setup and Upspin server setup. So in first part, user need to provide the client key pair, OpenStack username, and corresponding passwords, and tasks including the package installation and security rules and the security group, ports exposure, and finally the instance creation. And in the second part, user need to provide the domain for DNS management, and tasks include the domain setup using TXT record and the binding IP using A record, and also some binary file build, the Upspin service configuration, also finally the server startup. Next. So here's a quick demo of our Ansible playbook. User could simply type in one line command to run the whole playbook architecture. And you can see there are multiple tasks running in our playbooks. And the user could view the log of deployment in their terminal. So after waiting for a few minutes, users could view their deployment of the Upstream server on the OpenStack platform on website, like that. So we need to check whether our deployment is successful or not. So we just next. So we just design a simple test by put the hello Upspin into the content in the file of hello directory, and we use the Upspin get command to get the content from the hello directory, and you can see hello Upspin is printed out, so our deployment is successful. Next. So we also have some further development, like using an external storage volume and cross-cloud deployment. Next. So the first further deployment is using an external volume, which could help us make the data persistent. So in OpenStack, we manually attach an external volume, and in OpenShift, we mount a specific volume in Docker file. Next. And the second achievement is cross-cloud deployment, which could help us make the upstream server more secure. And the steps include the domain setup and binding store server with Google Drive account, updating configuration, and the final setup server. So as you can see in the picture right side, the user could access the upstream store server on their Google Drive. So currently, we cannot automate with playbook for this process because the URL authorization on web console. Next. Here's a quick demo of store server split. So as you can see, formally, the upstream store server has a space as 64 MB. Then we try to put upstream server binary file into our upstream store server, which is actually 16 MB large. So after waiting a few seconds, the file is successfully added into the store server. So as you can see, the store server currently is 80 MB large. So the deployment is successful. Next.
As previous introduction, we need to deploy upstream on OpenShift. So we try our best to deploy this. And we almost succeed. First, we create our own upstream image, which contains upstream package and server configuration. In the server configuration, there are 4 main parts. First is make specific ports exposed, which are 443 and 80, which ensure the HTTPS and HTTP connection. Second is mount a value for storing data persistently because container will be deleted if this container is closed. And then data stored in this container will lose. Third is to allow our service listening on specific ports. Finally is to configure our server certificates. Why we need to configure server certificate? Because we encountered some problems during the process of setting up server. First, we try to set up server like we did on OpenStack, but we failed because OpenShift cannot provide floating IP for container. In order to make our service could be accessed by external requests, we tried to bind the external IP, but it didn't work because external IP is used to connect different services in the cluster. Then we tried to access service by secure route by using pass-through TLS termination type. And then we can reach our service by the secure route. However, we cannot set up server successfully because we don't have the ownership of the host name of our service that the OpenShift provided for us. Because upstream uses the Let's Encrypt certificate to trust our server, but we need to have the ownership of the domain so the Let's Encrypt can issue the certificate for our service. Last, we tried to use the insecure flag to force upstream server on HTTP protocol. However, after reading corresponding source code, we gave up this method because it totally contradicts with upstream's main idea, which is to ensure the security of data. Finally, we tried to upload our own self-signed certificate to make our service accessible. During this process, we create self-signed certificates for the server side and download about certificates to the client side. And finally, our own self-signed certificates verified, and we set up direct server successfully. This is our demo of the whole progress. From the client side, we can see we successfully configured the upstream server at the OpenShift, and we created the root user for this server. However, we encountered a problem. A shutdown happened because we may have no permission to do that. From the server side, we can see the server uses the certificate provided by us and initialize the store and direct servers. but there are some problems because we didn't have the permission to make a new directory for the store server. Next, we will introduce what we have learned during our project.
To begin with, Upspin is one of the most important part of our project. So basically, Upspin is a suite of software components which can provide a secure data storage and sharing network. And the most important characteristic of Upspin is that it provides a global namespace to name all the files. And for a user, if he want to share his files, he do not need to download or upload several times to copy the data on different devices. All he need to do is to manage the access control for different users. And during the deployment, we've done a lot and we've learned a lot. So first, we learned how to use the DNS record to manage the domain. For example, we use the text record to let the key server know which domain belongs to us. And also we use an A record to create a subdomain. And also we dive into the documentation to learn the structure of Upspin about how the key server, directory server, and storage server are connected to each other. And he helps a lot when we actually deploy the service. And Ansible is also an important part of our project. So it is basically a automation tool, and it has already mentioned in our, my teammate has already mentioned it. So there are some components like inventory, module, task, play, and playbook. So we basically write a playbook to automate all the manual things that we need to do to deploy our service. And the advantage of the Ansible is that it is a human readable language. So it is pretty easy for us to start. And also it is easy to use. There's also an advantage that the environment of Ansible is pretty easy. So all we need to do is to install Python on our machine. And we first deploy our service on the OpenStack platform. And OpenStack is an open source platform consists of projects, each of which handles infrastructure services like as storage, networking, and computing. And there's one thing to mention that the OpenStack is an infrastructure as a service platform, so that it provides flexibility configuring our own infrastructure. So we work a lot on the OpenStack platform and we explore a lot. We do these several things like manage keys and security groups, expose port, API authentications, and also the to use our Ansible playbook on the using the Ansible OpenStack modules. And we further deploy our service using the OpenShift. And OpenShift is a centralized cloud platform for application. And like OpenStack, it is a platform as a service platform, so that it emphasizes software development. So it is much easier than the OpenStack to deploy our service. So what we have done, we use a Docker file, we create a Docker file to automate the Upspin service deployment. And there are two methods that we use. The first one is to write a Docker file and upload it into the Docker Hub repository, and the OpenShift will fetch our will fetch our Docker file and automize our service. And also we can use a GitHub deployment, which means we upload our Docker file into the GitHub, and the OpenShift will fetch the repo from GitHub to automate the service.
And another very important thing we have learned is certification. So certification verification is used everywhere as long as you're using HTTPS secured connection. And here we are going to talk specifically about self-signed certificate, which is a big issue when we are trying to deploy Upspin on OpenShift. So let's quick review some of the design decisions of Upspin. So first, Upspin focused very much on security, and Upspin used Let's Encrypt certificate for verification. So in our project, the problem is that we have no control on OpenShift host names, and because of that, we are unable to get certificate from Let's Encrypt. So the solution is to use the self-signed certificate. Next. Go back. So here is our layout of our certification. First, to use the self-signed certification, we need a self-signed root CA. The CA is a certificate authority which is used to sign different certificates. And in the root CA, we have our root CA key and root CA certificate. Next, on our server side, we keep a public key, which is used for creating certificate signing request. After sending that request to the root CA will actually sign the certificate for us and give back to the server. And now the server will have a server-side certificate, which is served on port 443, used for upstream server. And the last, on the client side, the client need to install the root CA into the client and will also get a system trusted. And after all of this, the client can send handshake request to the server and the certificate will be verified successfully. Next. So the tool we are using is called OpenSSL. We are creating or signing the certificates using the OpenSSL. And also, when we verify our upstream server certificate, we can see our certificate chain is showing the following figure. We have two layers of certification. The first layer, which has the common name of upstream.kapps.massopencloud. That is our server-side certificate. And you can also see the issuer is IaC root CA. And the next layer is our root CA certificate, which has the common name of IaC root CA. So it's a very simple layout. Next. So after all that, we keep receiving the depth lookup self-signed certificate error. So why is this happening? This is because OpenSSL is actually protecting our computer from attacking by unknown certificate. So to understand this problem, we look into the OpenSSL verification process. First, when we have a certificate, OpenSSL will look up the key of that certificate and see if it is trusted by our system. And if not, it will keep looking up the parent signer of that certificate until one of them is trusted and it will successfully get verified. But if we look all the way up to the root CA and still get no trust, it will return this error because anyone in the certificate chain is not trusted by our system, and it is a very dangerous situation. So it will return an error and preventing us from doing it. So to fix this problem, we need to install one of the certificate as a trusted CA. So in our project, we choose to install the root CA into our system trust, both on the server side and the client side.
So here we're going to talk about limitation and future work. There are many things that we have accomplished, but there are definitely much more for us to do in the future. For now, Ansible Playbook only automates for OpenStack and only supports for domain management on Cloudflare. And also OpenShift deployment isn't completed, and the store server is not well configured either. As for our future work, for the part of automation, for instance, we can have our users to choose from which cloud platform to deploy and choose from which domain management tool they want to use. And also here we can still like split up our directory server and store server by playbook. and finish up our deployment on OpenShift, as well as create an application to showcase our Upspin's features. And here we can jump into our conclusions. We have successfully deployed Upspin service automatically on OpenStack. Also, we have mounted external volume as well as setting up a separate store server on Google Drive. In addition to these accomplishments, we have successfully deployed Upspin on OpenShift manually with self-signed certificates. And finally, thank you to our professor, Oren Krieger, and our TA admin, and as well as our mentor, Patrick Dillon, for your patience and help throughout the semester. And that's all.